you know, container support, persistence, templating, all the things that make using Quarkus a really delightful experience. We will look at them through a live coding session, and great topic. Because Quarkus is really going up in terms of developer interest. More and more developers want to use it, and we have like a really great speaker to make sense of the topic today. Sebastian Dashner is a consultant, trainer, and developer. He's been working in the Java ecosystem for many years. Currently he works in the enterprise space, focused on Java, cloud, container technologies, DevOps, automation testing, and developer productivity. For his contributions in the Java community, Sebastian was honored with the Java Champion, Oracle Developer Champion, and Java 1 Rockstar titles. He's very active on social media. He has a blog that's well read by people in the Java community. And his goal is to spread knowledge in enterprise software development to ensure that engineers become more productive and better at solving problems. So a great speaker, so great session ahead of us. Sebastian, thanks for taking the time out to join us and do this webinar. Over to you.
All right. Yeah, thank you very much for this nice introduction, and also hi from my side. And I'm very happy that we can have now a lot of time for Quarkus and why you would like to code with Quarkus. And I will show you some reasons why it might be interesting for you, but also I want to show you a lot of live coding because I think that's just more interesting to watch. And you, of course, can get all of the code then afterwards. So that's open source, available on GitHub. So let me share my screen here. You should now see some example project that I'm going to use, Quarkus Playground. And then here are also some sort of code slides that I have. As for why you want to code with Quarkus in 2023. So yes, about myself very quickly. So I was also already nicely introduced. My name is Sebastian. I do a lot of stuff with Java, as you can see here with some titles. And basically, we would like to go over some reasons why you would like to code with Quarkus. And the first reason I want to give you is, well, the great and outstanding developer experience that Quarkus gives us, and especially the fast turnaround times. So what does this mean? Okay, let's start right into the code here. I have a project that is a Maven project, Quarkus Playground, that is built with Quarkus. We scroll down, we see it's the latest version, Quarkus 3. And how to get this? Well, you can get this on GitHub, of course, but how to create your own project? Well, if you have a look at the website, that is quarkus.io, you will see, okay, now Quarkus version 3 is out there, and you can learn more about it and some of the reasons why Quarkus is an interesting technology. And then if you go to start coding, you will go to code.quarkus.io and you can create your own Quarkus project. You can bootstrap this and try it out yourself. Or of course, you go to GitHub. At the end, I will share all of the links with you and you can try this Playground project, of course, as well. Okay, so what about this development experience and fast turnaround times? This is very interesting because what Quarkus does, and maybe you've seen this, besides the normal way how to build my project, for example, using Maven. So you probably know that I can build and package things together using Maven or another build tool, where I can say, okay, let's do this again, Maven package or Maven clean package just builds my project here. Okay, great. But there is an interesting other way that is Quarkus :dev. So what is that? That comes from the Quarkus Maven plugin, and it comes in the so-called development mode, which is very interesting because in this way, what it does, it builds my project, but it also has the connection to my source code and it starts up my enterprise application already. So this is very cool. It runs then under localhost 8080, and it still has the connection to the code. Okay, real quick, in my POM.xml, Quarkus :dev, where does this come from? It comes from this Quarkus Maven plugin that is part of a Quarkus project. And this makes enables it that is available. Okay, and then I can go and connect to my localhost 8080. And there is nothing here under 8080, but there will be something under coffee. So this is a coffee shop example project because I like coffee. So this just says coffee. It's like a hello response. Let's go to this. just for you to show you real quickly a little bit of code. What is this? This is a REST endpoint created with JAX-RS. This is now under the new Jakarta namespace. Maybe you've seen a thing like that before at path, at application scoped. If you're used with Spring, then this is very similar to a Spring REST controller, and it just will output something that is returned here from my coffee shop class. This is a CDI class that is injected here, and it will just return something. It will return coffee. And now the cool thing is, if I change something here, and I'm pretty sure you've seen this, it will reflect the change very quickly in my live application. So if I say, okay, this runs here, then very quickly it will restart. You see here that it detected a change. It will very quickly restart in less than a second and show me now the change. So I can do this again, can change something here in my code. I can invoke another HTTP endpoint, another HTTP request, and it will show me the change here. Now the change with a string is very simple, but you can change literally everything. You can keep it running in the background. You can change your class. You can move something. You can rename methods. If the whole thing doesn't compile anymore, doesn't matter. It will try again, try again, try again until it works. So this works quite nicely. Also, what is integrated here is a testing approach. So by pressing R for our tests, we will actually run the tests very, very quickly. And what happens here now is that you see the test now failed because I have a test that asserts for the string, but now I changed the string. So now the test is red. So let's change this back to the original. And now you see that the test is green. And you've seen how quickly this changed. I can do this again. Now it's red. And you see how quickly, even if I'm just switching over my screen here to this other window, it immediately reruns it and reruns it again, reruns it. You hear my keystroke. So this runs really, really fast, which is another nice benefit of this development experience that is included via this Maven and Quarkus tooling. Okay, so this works quite nicely already. It also actually integrates with integration tests. So I just stopped this real quick. Why? Because I have another test here available. You will see the coffee shop test, which is a very basic code level test. I mean, this is, very basic, just JUnit invoking this. But what I want to show you is how quickly it runs. And now the second thing is an integration test that already connects to my running system. So what this will do, it will actually go, this is another class that I use as a client. It will connect to localhost 8080 and invoke this and verify that then it is equal to a string. So if I change something here, I can also invoke this test. Out of the box, they are not included. Why? Because there is an exclude pattern that is set to something like *IT, because this is the same behavior like Maven behaves. Maven doesn't invoke the integration test IT out of the box. You probably know about this. There is a special plugin for this, the failsafe plugin. But if you set this exclude pattern to empty, then you can include them, and then it will run these tests as well. If I rerun this now we have two tests that are running, my coffee shop test and also the smoke integration test here. And now this, what it does, it will show us that also this integration test is then executed. So if I now change it again to question mark, then of course it fails because of my unit test first. Okay, let's adapt the unit test to also reflect the change to coffee exclamation question mark. And then if I run it again, then now we see that the integration test failed. So you see, now it's even faster than I can talk. And it runs again and it runs again. So now the way how to execute my test is really, really quick. And I don't have any waiting time. Why is this the case? Because the way how this development mode works, it keeps all of my classes compiled. And once I press that key, it just executes the test. And this is really, really fast. So especially the fast turnaround time for the tests run in a really nice experience. So I can run this locally, I can test everything, I can change production code and I see the changes. I can change test code level tests, but also integration tests or system tests that then connect to my application. I can change all of this very, very quickly and it just works. The nice story about this is it is integrated in Quarkus. This works out of the box. I don't have to add anything. I just need to generate my Quarkus project. I use the Quarkus plugin. I need this anyway. This is mandatory for Quarkus applications, and all of this is integrated with my development mode. Okay, so that's that. There is one more feature that I would like to show. which is debugging. This is also really cool. If I set a breakpoint here in my code, I can already attach a debugger here. So I can say debug for a local debug, and I can show you the configuration. I know this font is a little bit smaller, but it is just a remote JVM debug for localhost 5005. That's a typical JVM debug. And the nice thing is it is active out of the box. And now I can just point my IDE or any other debug tooling to it. And now it is already connected. You see the check mark here. And now if I invoke this again, then it will already capture the breakpoint. So it is very easy to debug something here because the dev mode has the debug enabled. It listens to this port. And once I connect to this port, then I can debug something here. Of course, there's nothing interesting going on here. Let's just continue this. But I could debug some code. I could go in here or maybe in here that I say, okay, please invoke this there again. And now for the next request, my breakpoint is captured here. So this is very helpful. The nice story is this is active out of the box. Once here you see it, once my development mode is running, it makes it possible to connect via this port. So this is really, really helpful. In general, the developer tooling is really outstanding for Quarkus. Nice thing is all of that comes out of the box. You don't really have to configure much, but it is also very extensive and extensible. You can use this for all sorts of ways. Okay, let's continue now. The next reason why I would like to code with Quarkus is that Quarkus comes with known APIs, at least if you're in the enterprise Java space. So all of these annotations and APIs that I just showed you are probably familiar. So this add path, this is nothing new. This comes from a standard. Originally, the package was Java X, or if you're in Quarkus 2 or lower, then it's still Java X. The new package is Jakarta for Jakarta EE. That is Jaxares. Add path application scope is CDI. At inject, this is from, well, originally an inject injection standard. So all of that is a known API, are known annotations. So for the most of the things, Quarkus doesn't really reinvent the wheel. It just includes what has been proven as a standard. So all of these standard annotations, Jaxares CDI, JPA, and whatever have you in the enterprise Java space are supported by Quarkus, and you can just use them. This is very helpful if you have existing code. So it is possible and also quite easy to migrate existing EE projects to Quarkus. And also the same is true for the knowledge that you have. So if you and your teammates have existing knowledge in the Java enterprise space, then you can just use this. Same for microprofile. A lot of microprofile APIs are supported, such as, well, health and config and all of the typical microprofile ones. And also Spring annotations are supported, but with a caveat. So of course, you cannot just take a Spring application and run it with Quarkus because it's a different runtime, but you can use some classes that contain Spring annotations. So there is a support for some of the Spring annotations in Quarkus. If you think about it, this also is, kind of makes sense, or, is not that far away, far-fetched, because Spring annotations, they work very similarly to what Quarkus does. So for example, a Spring bean is also a singleton. A Spring component or service could be very similar to an add application scope in CDI. Auto-wired is very similar to add inject. So this does work. And I think it is very helpful, especially if you have some existing code that you would like to migrate to Quarkus. Okay. For the next reason, I would like to code a little bit more, and I would also like to show some of the, well, extras that come in Quarkus. So basically, Quarkus supports a lot of the known APIs in the enterprise Java space, and also, of course, JPA with Hibernate as an implementation. And it also includes some other things that are Quarkus specific. And one thing is Panache. Panache is a very interesting project that is basically JPA, but on steroids, so JPA with some extensions that you can use just in a nicer way. How does this look like? Okay, for this, I would like to show you my project now in a little bit more detail, because this is my coffee shop here. At the coffee shops works in a way that I now can ask for coffees, so coffee orders, that I can create an order in the system and that I can query. So this application is basically an API for which I can order some coffee and, well, query some coffee orders in JSON. So it looks like follows. If I say I have some coffees, plural now, then this is a list of coffee orders in JSON. This list is empty, as you can see. And I can create and order some new coffee by HTTP posting something to this URL with content type application JSON. And I can say, okay, I would like to have, for example, type espresso as a JSON object. So this is going to be my coffee order, and I'm posting this to this endpoint. And then as a result, I get 201 created in my location. So then I can say, okay, great. Now there's the order in the system here, and I have type espresso. I can do this again, espresso, and maybe for a cappuccino. So then I have 3 orders in the system. Okay, very easy. But now these orders, they are just in memory. They're actually just in a hash map here, which is too simple. So it works for my demo, but of course, when I restart the application, everything is gone. So that's not that great. I would like to add some persistence now. Okay, so how does this work? I can include persistence. And if you want to know about this, a great way to look is into the Quarkus guides. They are there on the Quarkus website. And for example, if we search for Hibernate, or if we search for Panache, or Hibernate ORM Panache, simplified Hibernate ORM with Panache. So Hibernate ORM, I'm pretty sure you're familiar with. This is basically an implementation of JPA. JPA as Java Persistence API, or now Jakarta Persistence API. What we do, basically, we have relational database access that then is mapped to objects. This works in Hibernate for many, many years. Okay, now what Panache does, it makes it a little bit easier. We'll see how this works. First of all, we have to add some dependencies because our application here doesn't include this Panache and the Hibernate yet. So let's change this. How Quarkus works, this is very similar to Spring. We have certain dependencies that all come from this Quarkus POM. And then what we do, well, we add the Quarkus Hibernate ORM Panache dependency in the same version as the Quarkus version that we have. And then also we need a database driver. For this, we add Quarkus JDBC Postgres. We do this. And then what it does, my application is still running. So my dev mode is still running. This is very cool because it will actually just add and maybe even download, if it's necessary, my dependencies in the background. And now it restarted. Here you can see it, the application with the new features. So now I have Hibernate ORM Panache, Postgres, and so on and so forth. Okay, so what it does also, this is very interesting. If I didn't specify a database and I didn't specify one, I just add the dependency. If I didn't specify one, then it will start a dev service for me. So it will start a database for me. I can have a look at this. It uses test containers and Docker under the hood automatically. I don't have to do anything to start up a Postgres database. This just has been started. Okay, so this is kind of interesting. I can do this here, and then I can already use this. This happens if I'm not configuring anything here yet. So all of that is just a comment. So my application properties is empty still. That's why I didn't configure one, so that it just created one for me. Okay, now let's add some persistence. I have my coffee class here. This is my coffee order. These fields are public because of simplicity. They could also, of course, be private and getters and setters. Now what I do, I would like to make this an entity. This works as always in JPA. I annotate the class with @entity. I can also annotate it with, for example, table, if I would like to change the table name to something else like coffee orders, for example. And then I can say, okay, this should be an ID. It should be a generated value for the UUID. The type should just be persisted, and so on and so forth. So this is already sufficient. Okay, then what happens here? Well, nothing yet. If I just deploy this, it still works in the same way. So now what I would like to do, I would like to change my hash map to a real database. So let's just delete this. Of course, it doesn't work yet, but then basically the question is how to now integrate this panache, this Hibernate. And there are multiple ways. My favorite way is to use a so-called panache repository, which if you come from a Spring background is very similar to Spring JPA data repositories. So I can call this coffee repository. That will be an application scoped bean. To change this here, where I say, okay, this now should extend a panache repository or panache repository base. Implement as an interface. So what is the difference? Panache repository I could use for just being a repository for a specific entity, such as coffee. And if I want to define also an ID type other than per default that's long, or if I say I have UUID as an ID, as you saw here, so this one is a UUID in my case, I can just define the UUID here as well. And then I say, okay, coffee repository, now this works here, and I can then use it. So how does this work? I just can inject my coffee repository here, or repository, and say, okay, now I can use the repository to do all sorts of things. What this panache repository base does, this comes, of course, from Quarkus, it gives me methods to access the persistence here. And these methods are very convenient. So for example, I have some find methods. I even have list method that already return a specific list. I can also use a Java stream. I can do all sorts of things. If you have existing entity manager usage, you can also use the entity manager here. So it would also be possible to say, I would like to add the persistence context with entity manager. So this would also work. But, well, of course, now the repository gives me a better API or a more convenient API, because now I can just say find by ID. The type is correct because of the parameterized type, and this already works. Okay, let's do the persistence next. If I say I create a coffee here, how to persist the coffee? Well, repository.persist coffee. This will persist the entity and also make it a managed entity. That means that afterwards the ID should be set. So I can remove all of this code and just say I can return the UUID that has been created for my coffee, and this should work. Okay, and now how to get all of the coffees? You already see it. It has a method list all that gives me a list of coffees. So this is very convenient. I just have to list all of them with this method. Okay, great. So I can do this. And then hopefully my coffee is there. Okay, what I can do now, I can try this out. I can basically say, okay, list my coffees. Now the list is empty again. And now if I post something here, for example, I post a cappuccino. It didn't work. Why? I get some, you probably guessed it. If you're enterprise Java expert, then you might already be laughing because you say, okay, it's clear. Transaction is not active. So what does it say? Transaction required exception. Consider adding at transactional. It even tells you what to do. Yes, of course, if I want to now persist something, I need a transactional context. So here in this method or on the whole class, I can annotate at transactional. Actually, I have to annotate at transactional. Otherwise, it won't work. So if I try this now again, now it worked. So you see already, this is the nice story about the development mode. If something doesn't work, it would just try again and try again if I change some code. And now I can persist it. I can persist an espresso again, and then query for my coffees. Now I have 2 coffees in the system. Of course, if I now change something and my application restarts, let's just try this. I change something in my code. Now everything is gone. Why? Because this development dev services database that has been included automatically drops and creates the database here. You see this Hibernate property here. That is per default. It is very helpful during development, but then if I step one step further, if I say now I would like to test something, it might not be the easiest way to use this dev services. So now I stop this again and I use my own database. How does this work? Well, easy. I just need to go to my application properties and configure this myself. For example, I say I would like to have my own URL for local host, for example, for my local purposes. I can run my own database here. I can say, okay, for example, during dev mode, use create, not drop in create, only create. On production, use none. For example, I could have different ways to do this. If you prefix a Quarkus property, all of that is documented, of course, with %dev, then this is only active during the development mode. And this is active in the production mode. We will come to a production mode in a second. Okay, so this then works. Now, what if I start my development mode again here? Then it tries to connect to the database, of course, which now fails, as you might expect. Why? Because I have no database running yet. So it tries to connect here to localhost. Okay, so of course I need to run a database first. I have a script to run this locally. Of course, there are many ways to run your database for development purposes. I think one of the easiest ones is to use Docker containers and then just to start it up. So that's what I'm going to do. I say, okay, please run my database here. And then after a few seconds, I will have a Postgres database that is up and running. Okay, now I can restart my application and now everything looks good. And now if I query for my coffees and I create a coffee again, 1, 2 espressos and cappuccino. Okay, now I have 3 coffees in the system again. And now if I stop my application and restart it, they should still be in the system because I'm now not dropping the table. Now I get a warning that the coffee order table already exists. That's okay. And now they're still there. I can even connect to my database, pSQL, saying localhost. This is Postgres user. And I see that the table is here. I can say select from coffee orders. And I have my 3 coffee here. So this schema has been created by Hibernate because of the create property that I've set. Okay, great. So this is very handy to do this with a so-called Panache repository because it comes with very nice code that is already included. If I would like to have my own business business use case methods for querying, then this is a great place to add them. I could, for example, say I would like to have a list, my own list of coffee. Now, not list all, but basically saying something like list all espressos or list all cappuccinos. And then what I could do, there are a lot of methods available that I can use, for example, for specific querying, for filtering, for pagination, all sorts of stuff. Here, I would like to say, okay, just query for the type equals espresso. So this would work as a very easy example. And then I say I include this as my own, use case specific method, which is very nice here because then I can go to my coffee shop and say, okay, for get coffees, query not all of the coffees, but now just list all espressos instead, just, as an example. And then what I can do is I can query my coffees. And now instead of 3, I only get 2, only the espressos. Or undo this again, and then I get my 3 coffees again. So you see that this Panache approach is a very nice way to just add now some specific querying or specific persistence logic that is included or delegated into this coffee repository there, which is very helpful. And that is the reason why I'm a fan of this Panache technology with persistence here. That just is a better way of how to do JPA and Hibernate that is fully included in Quarkus. You can have a look at the guides. There's a lot of stuff that you can do with it. The good news is if you have existing code, all of that is compatible. So Panache is fully compatible with everything that is included in JPA. You can also mix and match JPA and Hibernate and Panache approaches. All of that will work. So as long as you run in a Quarkus application with this Panache dependency, this will just work. Okay, now let's move on a little bit to Well, how to build our application, and especially what is a nice out-of-the-box supported feature in Quarkus with these, well, what I call thin deployment artifacts and with the Docker support. So this is kind of cool. If I don't use the development mode, but if I would like to have my application like it would run later in production, I usually build it here with my Maven clean package or Maven package, for example. And then at the end, it will just build the application here using this Maven plugin. We will come to this a little bit later. I will say some more things about it. But what is very interesting is the way how the target directory now contains this Quarkus app. So here we will see that what I can execute with java-jar lays under Quarkus target, Quarkus app, Quarkus run. Okay, so I can execute this and then my application is running. This is now my production sort of profile or my application in the same way how it would run in production. I could use this and then I could also use this to get my coffee that I created before. Okay. Now, let's stop this again. This was not the interesting part. The interesting part is what is supported here is the so-called thin deployment artifacts. Why? Because this is the application that I'm starting, Quarkus run.jar, and you see this is very small, like only 600 bytes. That's not nothing. Okay, so where is all of the code if this is very small? Well, here you can see there are 3 directories where this is basically contained. So I have directories for just all of my dependencies for the whole Quarkus runtime, and I have my application with my actual application classes, like the classes that I write and that are then compiled. Why is this so? Why don't I just use a fat jar approach like other things like Spring Boot? Well, because it makes a lot of sense to have this for Docker containers. Why? Because of the way how Docker containers work. I have a Docker file here with my, well, I use our own base image for my own JVM, not mine, but like a custom one or not the OpenJDK one. And now if I would like to add my dependencies, I add them in 4 layers. And this is actually, it's a little bit, well, more steps, but it is a huge advantage in the container world. Why? Well, let's try out and build this, Docker build. I use my own repository for testing purposes. I can say, I would like to have this just, call this temp, doesn't matter, just as a build. And here you will see, okay, it builds it basically at the first time, all of them. And then if I build my application again, and if I didn't change my dependencies, then you will see that it will use the cache and it will work very, very quickly. So now this runs really quickly, and you see it even more so if I try to push it. Because the first time, as you see, it pushes a lot of it, you know, all of the whole hundreds of megabyte, and, you know, need to wait a little bit until this pushes. And yes, on the other side, you also need to pull it. So this is a little bit more effort. Okay, now we're done in a second. But now the good news is once you've done it the first time, then because of this thin deployment artifact, you will save a lot of time, a lot of build time, and especially a lot of transmission time. So let me build this again. And now I do the Docker build again, and I do the Docker push again. You see now this works really quickly. And now it just pushes a few kilobytes, and now it's already done. So even if you have a very slow connection, if you're somewhere out in the nature, you can still use this approach. Why? Because of the thin deployment artifact that is supported out of the box. So you don't have to do any specific work. Quarkus has been created with this cloud native world and containers in mind. So this is the default way to ship Quarkus applications. It is optimized for containers. You get all of the benefits here. You don't have to think about it. You can use the Docker files that are provided with Quarkus and then just go, and it will be optimized already, which is another nice way how Quarkus really makes sense in a cloud native world. Okay, there's one more technology that is Quarkus specific that I would like to show you. This technology covers server-side rendering, especially templating. It's called Qt, Quarkus templating engine, Qt, that's why the name. Templating engine, it comes with, well, templating. and especially integration for HTML templating. So how does this work? Let's say I would like to have a very basic website that lists my coffee orders. What I can do, I could now say I would like to have something like I call this order controller. I would like to have, I can do this actually with JAX-RS and have something like orders HTML a page. And I can say produces. Now I don't want to use JSON, something like this. That is media type application JSON usually, but now I would like to have HTML. So I have text HTML. I can find it here, text HTML, and this can produce HTML. There's nothing wrong with it. It works very nicely. I can say, okay, list my orders here. And then I can say, okay, return. This is now not valid HTML. I just have this for some, testing purposes. And I can say, okay, please have the HTTP get on orders and return this here. Okay, so that's kind of interesting. I use this here, and then I can say, okay, if I, now let's run this again in the Quarkus development mode. Oh, I have the wrong imports here. It already complained, but I didn't see it. Of course, that's JAX-RS produces. And now I can say, I would like to go to orders HTML, and I get this response here. I can open this up in the browser and say, I would like to open this up here and get my coffee orders. Okay, now this is not templating. This is just boring. I just created a string. Let's do this in a little bit better way. What I would like to include is another dependency that is called Quarkus Qt. Or if I include this with my REST Easy, with my JAX-RS example, then I can use Quarkus REST Easy Qt. And this will include it. Now you see that my application quickly restarts again. And now that is included. What I can do then here, I can add what is called a template. And these templates with the name orders HTML, per default, they reside under resources, templates, and then the name of the template, templates/orders HTML. So this is a page now here, orders HTML, for which I can now do a little bit of a better orders page. I can call this coffee orders. And here I say coffee orders. Okay. And then what I can say, template render, and it will render this template. And then what I do in my browser, now I get my coffee orders. Okay, here you don't see the difference, but now it is rendered via this template. Or I say template instance, because this JAX-RS then knows about the template instance type. Okay, so this works. But again, this is just a string. This is for now, it is boring. What I would like to add, of course, would be some sort of templating. There is a syntax for this available, which is very interesting. So you can check this out in the Quarkus guides. For example, I can say for orders in orders, please add something here. So for example, I could say have an unsorted list and then have a li for all of the orders. And I can say, okay, order ID, for example, order type. You will see that the syntax is in this curly braces. And then what it will do, it will just, well, give me an exception. Why? Because of course I forgot to add the orders. How it works here, this is a typical action-based MVC approach now. I need to add the coffee orders to my data. So I have to say I need to add something here. And where do the orders come from? Well, of course, from my coffee shop, right? Because now I can use dependency injection, of course, and I can access the coffee orders here, orders. And now let's try this again. Now it works. Now you see the coffee orders are included here. Okay, this looks weird because of the ID, but you get the point. I can have a list of my coffee orders here. Okay. Now, what is also interesting, the typical use cases that you need in some templating language are well included and they're thought of. So for example, here I can say order underscore count. For example, I could say, okay, this already includes, accounting. I could have an index here. I could say counting dot. I could say, is it the last one? So the typical one where we say put a comma after every element, unless the last one, except the last one. That's a very typical approach, right? So we can have something like as next. And all of that you can check out in the documentation. So I want to have a comma, but only if it still has a next order. So here you say we now have 2 commas there, but nothing after the last element, things like that. So this is a very very helpful and very pragmatic and usable templating language here that integrates very nicely, especially for server-side HTML. It doesn't have to be HTML. It can be text. It can be for emails. You can render anything, some configuration if you want, live in the application. But this is very helpful, well, especially for HTML, but for any templating approach. So that's another reason why I like Quarkus. This Qt technology is very cool and helpful, and I use it also in some client projects. Okay, now let's move on with some more Quarkus build time features. One thing that I didn't talk about yet was this obvious feature that is included if we look at the website, that we say, okay, we can have something for containers and native development here for Kubernetes native and also for native builds. Maybe you've seen this. If you use Quarkus, you can say you can go and have a native build with GraalVM. This is very interesting, but there's also a misconception. You don't have to use Quarkus with the native build. You can use just Quarkus as a regular Java application, which is what I did. I used java-jar to run it. You also don't have to use OpenJDK. You can use any JDK. You can use any JVM that you would like to have. This is also very interesting for projects. If you have an existing DevOps structure with some JVM of your choice, maybe you have a contract with one of the JVM providers, that works very well with Quarkus. Okay, now where is the point of using Quarkus with such an approach? Well, easy. What Quarkus does, it does all sorts of work during build time, exactly here in my Quarkus Maven plugin, and it says it does the Quarkus augmentation. What is that? Well, let me tell you, how does usually enterprise Java work if you have some application server or if you have a Spring application? Typically, how this works is that your application starts, and at application startup, you scan the whole world. You scan all of the classes that you have. You search for specific annotations like this add path, add produces, inject, things like that. Why? Because all of this programming model is very declarative. You don't tell the application how to inject something. You just say, hey, I would like to have an instance of my coffee shop. How this is done, this is the problem of the runtime, right? Now, of course, this is a lot of work at startup time. So your application starts, you have to scan for all of this. Your framework has to build up some meta model. It has to do the injection. It has to have the life cycle of its beans, which is a lot of work. But of course, also in a cloud native world, in a modern application, we don't do this in a very dynamic way. Once the application starts, it actually doesn't change typically. So this can be done earlier at build time. This is what Quarkus does. It does all of the augmentation, all of this extra work at build time already. And because of it, it comes up with a much more optimized application that is also more static. So basically what it has, the application that you can start up with java-jar, this Quarkus application, Quarkus run, this starts up extremely quickly, like in less than a second, because all of the work has already been done. This already works, it starts up and you get the benefits. So some of the benefits are, well, it starts up faster, and also you have way less resource consumption, because you can get rid of all of the functionality, a lot of the functionality, a lot of the extra dynamics that you don't need. Once everything is built, you don't need to ship some sort of reflection magic resolver. You can be much easier. much simpler. And in this way, this makes a lot of sense, and it will save you a lot of resources, always. Now, another benefit of this approach is that you can go for native builds. What is a native build? Well, a native build uses a technology such as GraalVM or Substrate VM, to be more precise, to compile this to a native executable. Native means then it is native to your CPU architecture. You can just start it up and it will run without a JVM. Then you don't need a JVM anymore. Then you have an executable there. Okay. Then do you have to use this? No. Does it make sense? It depends. So I will talk about this in a second, but basically the good news is you always, just by using Quarkus, have a lower resource consumption. If you compare this, you can check out the website. It compares it with Spring and with some more traditional application servers. This always will save you megabyte and, in memory consumption, which in the cloud world, this directly translates to money. If you can run the same application with less resources, it will save you money, especially if you have many, many instances. If you work in a big corporation, you have a lot of workloads, this will save you a lot of money. So that's a nice story. And also in the world of eco-friendliness and CO2 consumption and all of this footprint, it is also more eco-friendly. So just by using Quarkus and the build time optimization, how Quarkus works, well, we're more friendly to the environment and we also save some money. So it really makes sense. And you don't also have to go native. You can, but now the question is, should we then go native with the smaller resource consumption and the faster startup time? It depends. So would I recommend to go native? Actually, not per default. I use Quarkus a lot. All of my enterprise projects are now powered by Quarkus. And almost all of them run in a JVM mode. So they don't run in a native mode, but in a JVM mode. Why, you might ask, if the native mode is better? Well, it depends. It's not always better. It depends. So the downside of the native mode is it takes a lot of time to build, and really a lot of time. It's not like in seconds, but it takes a few minutes just for a Hello World application. It is a lot of effort, and you don't do this locally typically. You would do it on a CI/CD environment. But then on this CI/CD environment, you have to test it again. You have to do all of that stuff like extra because it's a different build. And also in production, it runs a different binary. It's not a JVM anymore. And if your operation teams has experience how to deal with a JVM, how to take a heap or a thread dump and all of these things, a native build will just behave differently. This is also a question. And so it might not necessarily make so much sense, which is why it is much easier to just go with the Java approach. It will also save you quite a lot of resources, as you can see here with the comparison. And usually it starts up fast enough. One of the exceptions are when you have to have a scale to 0. If you have scale to 0, then it's really important that also the first request answers very quickly. So then it might make sense to boil this down to native executable. Otherwise, it's not really required. I can tell you from my own experience, almost none of my projects use the native build, but they use Quarkus in a JVM mode very happily. This works very well, and it will save you money with the resource consumption. Okay, so that's that. We talked about the eco-friendliness. And the last thing I want to point out is the whole ecosystem of Quarkus, the documentation and the support that you can get. This is really helpful. And I can say this myself. I provided some pull requests and also some issues that I found some bugs in the beginning of Quarkus. I've been using it now a lot or for a long time, and they have been fixed very, very quickly. And that is also really important for big enterprises. If you use it and if something doesn't work in the way how you would expect it, this ecosystem works really well. People are very friendly. The documentation is pretty good. The support is really, really good. So that is another reason why you would like to have a look in Quarkus. Okay, now I showed you a lot of examples, and this is my list of reasons. Mostly the development experience. And I can also tell this to you. If you're unsure whether you would like to give Quarkus a try, just try it. Try it out for yourself. You can do this just in your own, free time, and try out the developer experience. And you will see that this is really fun. You will just like it because it's fun and cool to to do and to use. And, then you can see it yourself. If you would need to convince somebody in your organization, you could definitely have a calculation with the resource consumption. This makes a lot of sense for the same functionality. You will also be a little bit greener by doing so. So this makes a lot of sense, but especially from a development time spent, the development experience is very nice, and all of the support for the technologies there. That is also very helpful. Okay, so what else? I will just now quickly share with you some links. At the end, also on my slides, you will see this. My Quarkus Playground project is there, so you can just try this out yourself. This is there on GitHub. Also, I have some more resources that I think might be quite interesting. So if you want to learn more, you can follow me on social media or on YouTube. I have a YouTube channel for which I do quite a lot of Quarkus stuff here. So this is definitely something that you might want to have a look at. And also I have some courses available that you see for effective development with Quarkus, and also testing with Quarkus, because this is also a very important topic, both of them. And that is an on-demand video course. You can check this out. Also comes with a lot of code. Also, what I wanted to do to make these courses more available for a broader audience, I included some purchasing power parity program. So if you are located in a country where there's typically a lower income, I know a lot of you are watching from India, this is definitely the case, then you can check this out. This is included and you will get a big discount. So I will provide you the links there. This might be interesting for you, especially if you check out the content that I have. If you found this Quarkus technology interesting, I have a lot of stuff there that you might want to have a look at. So you see all of that on my Twitter, on my YouTube channel, of course. I also have a blog post, my website, and then the courses that I just mentioned. You can check this out here as well. Okay, so first of all, thank you very much for your attention. I hope I could spark some interest in this Quarkus technology. Now, I'm curious if you have some questions. You can, of course, ask them if you're there in the stream live. Otherwise, I will also we have a little bit of time left. Can also talk a little bit more about this whole build time and the native build, because this might be interesting, or anything else that, well, you would like to know more about.
Right. So, Sebastian, we will discuss, I've got questions and I'm compiling a couple of them. Okay. So, we could do it either ways, we could just go ahead, do the build part, you could talk about it, and then we could come back to the questions. If not, we could take the questions now.
Well, as you wish.
So we'll talk about the build thing. We'll continue with the session, and then we will do the questions at the end.
Okay. Okay, so sorry, say again. So what should we?
Oh, no, you said you'll talk about things around build and all that, right? So is there anything?
Well, we
else?
already did this. Then I would actually prefer to talk about the questions that people are interested in. So I already gave you my quick answer for what I think about the native build. You will find more about this particular topic on this course and in my YouTube channel. And I would say, let's go over the questions that the people have in this session.
Okay, yeah, cool. So first of all, thanks a lot for a brilliant session, because it's really surprising to see that the resource consumption, you'll have a lower resource footprint with Quarkus, because the developer experience is something that we know, but that's interesting to know, and also really interesting to see that whole templating, right? So in a typical enterprise application, you tend to use templating quite a bit. So Qt in that sense, I think is very interesting. So thanks for doing this really, really hands-on, immersive code walkthrough. So really enjoyed it. Like I said, I have some questions that I have here that I will prioritize and read them out to you. Yeah. So this is about okay. So if any companies among the big tech in the big tech landscape that are using Quarkus, any interesting examples directly?
That I know directly. So some of them I cannot share because of NDAs, because I work as a consultant with my clients. What I find very interesting, and I've now used Quarkus for for a while. So it has been made available publicly in the beginning of 2019. And it is very interesting that actually all of the companies I know, enterprise companies are at least looking into Quarkus already. And some of them are actually already using it. And this is interesting because I usually work in the enterprise space, and sometimes I work with, like European and German speaking companies who are more, let's say, conservative than others. And even the more conservative companies are already looking into Quarkus or are already using it, which is very unusual because the enterprise space usually works very slowly for, adopting new technologies. So this just says that people see a demand in, first of all, the development experience, but then also in the improvement in resource consumption, which makes sense because companies can save a lot of money by doing this. Actually, to answer your question, all of the companies that I know now, or all of the companies that contact me and that I work with, are at least looking into Quarkus. So they're at least evaluating it. Some of them say, okay, we have existing Spring knowledge, we're happy with this. So we don't, we not necessarily want to migrate, which is totally okay. But at least all of them are looking into it, and a lot of them are using it in production already. So I've been doing production Quarkus project since the end of 2019 in companies, and it definitely is. It is very stable, has proven itself. It works really well in production, and yes, there is enough, I would say, experience or good cases for running it in production in the last years already.
Right. The other question is with respect to I/O. I/O operations are typically, are they faster, slower compared to Spring Boot, which happens to be the most popular framework, right? At least here in India.
Mm-hmm.
So are the I/O operations, how do they compare? Is Quarkus faster, slower?
Just for I/O, I would say it's very similar. It both works with Java, and of course, in the runtime, both of the frameworks, they optimize a lot. So Quarkus, for example, all of it is internally built on Vertex, which is a reactive technology. So even if you don't use reactive approaches, you've seen my code is very simple, just synchronous calls, but internally it is heavily optimized. If you say you would also have some reactive approaches for just further optimizing it, although I would say it's probably not necessary, you can do so. But I also would say in Spring, it is also pretty much state of the art. So the advantage that Quarkus has is it is slightly newer. So, there's almost no legacy there on the implementation side. So this works extremely well. From the resource, from the optimization perspective, if you would make a benchmark, I think, it might be slightly faster compared to more traditional enterprise Java. But usually I/O is not really a problem, to answer your question. So usually the problem lays not in I/O, but either in threading, because if you have too many threads, or if you have something that in a container-based cloud native fashion works, a little bit limited, then this is more a problem, or the resource consumption, for which both of it, Quarkus really takes care quite nicely. So to answer your question, I/O is, from my experience, almost never really a problem. The performance specific is, as I said, slightly better than other approaches. The throughput is extremely good with the JVM mode, especially. Why? Because of the JVM hotspot, just-in-time compilation. This is always the case with Java applications. So all of Java applications run extremely fast in a modern JVM version. And yes, other than that, there are not really, big problems with regard of choice of technology, I would say.
Right. Yeah, thank you. And then the other question is, there's this person, his name is Ankur, and he struggled to get GraalVM installed. So are there any resources where, he could?
So try out the latest Quarkus version, because this was an issue in the past that you have to had Quarkus installed. But now what is nice, if you have a latest Quarkus code generated, you don't have to install GraalVM. If you don't have it locally, it will download a Docker container that then builds the native build in a Docker build. This is actually the easiest way to do it. You don't need anything, you just need Docker installed. And then you can just have the native build with this approach. That's how I do it. I also don't have GraalVM installed. I just have a JVM. And then if I say, Quarkus package type native or something like that, if you set this property, if you don't have GraalVM installed, it will have the Docker native build. So it will build it using a Docker container with a specific Docker image. And then this just works. So since I used this approach, I had no problems with the native build. Try this out, and this should work.
Okay, cool. And I think that's about it, for today with Top of the Hour. Thanks a lot, Sebastian, for doing this really interesting session. On behalf of the entire startup community, I would like to express my gratitude for doing this with us, and we hope to someday bring you back for another session.
Yeah, thank you very much, and for everybody watching, thanks a lot for watching and for attending. Bye.
Thank you. Bye-bye.